Hello there. My name is Shayan Shiran, and in this video, I'm going to talk about Microsoft Azure. I'm one of the members of Hoopad's R&D department, and I'm more than happy to discuss another topic for you. Uh, but before I start talking about Microsoft Azure and the table of contents, I would really like to say a quote from the late Firuz Naderi. Uh, in one of his speeches, he said, "Becoming a decent human being is more important than the work I do in NASA." Uh, yeah, you guys are laughing. I don't know much about him, but he was a great man uh, in NASA. All right, let's go over the table of contents. Uh, we can group Azure core architectural components into two groups, Azure physical infrastructure and Azure management infrastructure. And I will talk about them thoroughly in the coming slides. And then I will talk about Azure compute and networking services. Uh, The physical infrastructure of Azure starts with data centers. As you're seeing in this picture, this is Facebook's data center in Sweden. Uh, and as you can see in the picture, uh, they are they are resources arranged in racks with dedicated power, cooling, and networking services. And data centers have hot rows and cold rows for their cooling system. It's really a fun topic to talk about, but it's not for this specific topic. So we go to the next slide. I just wanted to show you how a data center looks like. And we have seen these kind of data centers in movies. I myself haven't seen any in real in my entire life. So for now, if we talk about cloud computing in, I don't know, Microsoft Azure or AWS or GCP, we see some concepts. These concepts are somehow similar in these three cloud providers. One of these concepts are regions. A region is a geographical area on the planet that has one and potentially more data centers nearby that are connected through low latency networks and links. Uh, Regions have availability zones, have one or multiple availability zones. It is said that it's efficient. If you want to reach a resilient infrastructure, you should have three availability zones inside an Azure region. And what is an availability zone? Again, availability zone is a shorter scale of a region. You have databases, you have data centers inside each availability zone. Again, you can have one or multiple data centers inside an availability zone. The availability zones are connected through highest speed private fiber optic networks. And And again, it's better to have, for example, three, four data centers in an availability zone. Uh, the next thing that is another concept is region pairs. Uh, Most of Azure regions are paired together within another region in the same geography. For example, West for example, Microsoft Azure in West US is in pairs with Microsoft East, for Microsoft US East. Uh, and the reason for that is it allows us to replicate our information and resources. For example, if I don't know, power outage happens, a natural disaster happens, civil unrest happens. In that case, another region has all of the data and information that the other region has, and it can bring it back up in case of these events that I said. And these region pairs are said to be 300 miles away from each other. They should be like that, but they're not always like that. And there is a direction between these region pairs. Uh, Sometimes in regions they have a two-way direction. I mean, for example, as I said, for example, U.S. Microsoft East is U.S. Microsoft West pair. I mean that the information and the resources of US East is replicated in the data centers and availability zones of US East, but it doesn't go the other way around. US East, for example, replicates its data to US North. This is called one-way direction between the region pairs. And there are some other kind of regions, and I will mention them in the coming slides. There are some advantages to these region pairs. As I said, if an extensive Azure outage occurs, one region out of every pair is prioritized to make sure at least one is restored as quickly as possible for applications hosted in the other region. So you do not have to worry about downtime for your applications or etc. There are two other advantages for these region pairs. Planned Azure updates are rolled out to paired regions, one region at a time, to minimize downtime and risk of application outage. And the other one is data continues to reside within the same geography as its pair, except for some specific regions. We can see what these regions are, but it's not necessary for us right now. Uh, as I said, the data continues to reside within the same geography as its pair for tax and law enforcement jurisdiction purposes. Um, we have another concept called sovereign regions. Sovereign regions are instances of Azure that are isolated from the main instance of Azure, and you may need to use them for compliance and legal purposes. For example, U.S. Department of Defense Central, or U.S. Government Virginia, or U.S. Government Iowa, and uh, more states use these kind of region because they are physical and logically network isolated instances, which are programmed for just US government agencies and their partners. And the ones controlling these data centers and who are in control of these regions are some trained US personnel. Means they may be classified according to their use. We don't know how they are using it. For example, another sovereign region is China East, China North, and etc. And there is a company named 21 ViaNet. They have a special contract with Microsoft that Microsoft doesn't have any ownership uh, on the data centers. 21 ViaNet has the power over all the data centers across China East and China North. And I think we know what the reason is. They want their country's data. Uh, they do not allow Microsoft to take control for their data centers because of their privacy and because they want to because they want to steal their people's information. That's what I can say for sure. Because China is a communism country, and I'm not going to talk about that. Uh, All right. Let's go to the management infrastructure. Now the physical infrastructure of Azure is completed. We don't have anything, any other special things here for the physical infrastructure. So let's go to the management infrastructure. Uh, Resource and resource groups. Resources are the basic building blocks of Azure. Everything that we create, provision, and deploy are resources. For example, virtual machines, virtual networks, databases, cognitive services, and etc. They are all considered resources. And each resource in Azure is required to be in a resource group. Each resource group has multiple resources, but each resource has to be in just one resource group. One resource cannot be in multiple resource groups, but a resource group can have multiple resources. Uh, And the other thing that we can talk about is Azure subscriptions. In Azure, subscriptions are a unit of management, billing, and scale. Everything in Azure happens at the subscription level. People that are new, just like us, to Microsoft Azure think that Azure has enough hierarchy for its management. It has resource groups. The resource group manage the resources, and we do not need any other a specific component or concept to manage these resources, but we need these kind of concepts. Subscriptions are the ones that are in control of resource groups. They manage the resource groups. Using Azure requires an Azure subscription that comes with an Azure account. As you can see in this picture, uh, an Azure account can have multiple subscriptions. For example, this one has a subscription for its development, it has for its test, and it has a production subscription. And again, each account can have multiple subscriptions, but each subscription should be in one account only. We cannot use, for example, we cannot use this specific dev subscription in another account. We have to, for example, we have to buy another subscription for these, for the other account. A subscription provides you with authenticated and authorized access to Azure products and services, and it also allows you to provision resources. Uh, an Azure subscription links to an Azure account, which is an identity in Azure Active Directory or Azure AD, which I will mention then uh, in our future presentations. It's in Azure's identity topic, and I will talk about them in our next presentation. Or the subscription can be in a directory that Azure AD trusts. And the other one, and the other concept in management in Azure's management infrastructure is management groups. This again helps with uh, the organizing of subscriptions. Another concept is management groups. Management groups are the final piece of the management hierarchy that we are going to see in the next slide here. Management groups are the final piece. Resources are gathered together in resource groups, then resource groups are gathered together in subscriptions. And it helps us organize and manage these resource groups and subscriptions better. And And that's it. Here in this slide, you see a picture of the hierarchy between management groups and subscriptions. As you can see here, the root management group has uh, 5 levels, and 3 of them again are management groups. It has 2 subscriptions, it has 3 management groups, and again, the management groups are divided into, for example, subscriptions. And here they can be, uh, for example, one of these levels can be a resource group as well. It's not necessary to be subscriptions, because the subscriptions are because resource groups aren't necessary to be in a subscription level. They can be alone. They are not. It's not essential for resource groups to be in a subscription, but for ease of use, it's better to be. It's better for us to have resource groups in subscription levels. And these have some, and there are some important facts about the management groups. We can have up to 10,000 management groups in a single directory. And the other important fact is uh, we can uh, we can have up to 6 level of depth in uh, these management hierarchy. And another important fact is we can set policies for these management groups and these subscriptions, which uh, inherit from their upper level parent. Uh, and now the core architectural components of Azure uh, is finished. And let's talk about the compute and networking services. The first resource, as I said in the previous slides, is the virtual machines. One of the first ones is the virtual machines. And virtual machines, we know them as images. We call them images. Uh, and as you can see in this picture, we have a virtual machine. As you can see, it just uses the hardware, the physical hardware uh, of a device, for example. And it has its own OS, its own apps, services, kernel, and it has a. And the reason that I brought this picture here is because they have a huge difference with containers. Containers are inside the host OS. They are not separated. They are not. They do not have. Uh, they do not have a single OS embedded in them. They don't have any OS. They don't have any OSs. That's the huge difference. That's the most important difference between virtual machines and containers. Containers are for example, in this picture, we can have a container here in the host OS. But VMs are an ideal choice when you need total control over the operating system. These are its use cases, and it has the ability to run custom software, and we can use custom hosting configurations for VMs. Uh, in Microsoft Azure, everything that we do, we need to have a virtual machine. I mean, you have you have to use a virtual machine for everything. And we can use containers, but yet again, if we want the containers to be run, it needs to be on a virtual machine. Uh, there are two concepts in virtual machines. One of them is the scale sets, and the other one is the availability sets. If we create multiple VMs, we need to make sure that they are uh, identically configured, and then we should set up the networking parameters. And for example, in a system that wants to measure the fluctuation demand, sometimes it's necessary to have more than one or more than two virtual machines, because uh, the current virtual machines uh, do not respond to high requests, uh, to high amount of requests. So scale sets increase have the ability to increase and decrease the number of VMs according to our use, and we do not need to configure them manually. It does these configurations automatically, and that's the reason that we use scale sets. And the other concept is the availability sets. Availability sets are again another tool in Microsoft Azure that helps. They group availability sets into two categories: the update domain and the fault domain, and these two have the same purpose. They want to prevent the downtime of the applications and the risk of the downtime by making sure that other, for example, resources are up and running, other VMs are up and running. Uh, for example, if a I think I have it in. For example, if a network outage occurs, the availability sets make sure that we have other VMs to replace the one that has gone down. Uh, the update domain groups VMs that can be rebooted at the same time. This allows us to apply updates while knowing that only one update domain grouping will be offline at a time. And default domain groups your VMs by common power source and network switch. By default, an availability set will split your VMs across up to 3 fault domains. Uh, and there are some use cases for and examples for virtual machines. One of them is during testing and development. Uh, VMs provide an easy way to create different OSs and run different applications on them. So the testing and development uh, teams are able to bring up a new VM and work with it. It's really easy for them. Uh, its other use cases when running applications in the cloud. As I said, for example, for the system that wants the fluctuation demand handled, VMs are for example, it uses VMs. The system uses VMs, and when the amount of requests are getting higher and higher, it increases the number of VMs, and again, if the traffic is low, it decreases the number of VMs, because we are going to get charged for every VM that we are using according to the price policies of Microsoft Azure. Another use case is when we want to extend our data center to the cloud, we can use virtual machines. Uh, for example, if a physical failure happens in a physical data center, we can use Microsoft Azure virtual machines to run our applications on it. Um, and another thing is for the during disaster recovery that I have mentioned this topic, and I said how it happens. Uh, again, we can have multiple VMs running, for example, in another region pair that I said. because if a region uh, is out of service, is totally out of service, we can use VMs in another region that I discussed, that they are in pairs. We can use them in our disaster recovery. Uh, when we provision a VM, we will also have the chance to pick the resources that are associated with that VM, including the size or the storage disks. It means we have the ability to pick, for example, how many number of process cores we need. It's up to us. We can just set these up. Uh, and as you can see, we can pick the networking. For example, if we want to use virtual networks, public IP addresses, and port configuration, we can do all of that. It means it gives us the power to pick uh, the things that we need. Uh, and it gives us the ability to achieve the most out of a VM. Uh, another resource is Azure Virtual Desktop. And it enables us to use a cloud-hosted version of Windows from any location, works across devices and different operating systems. Uh, and it also lets us use Windows 10 or 11, the enterprise version, and the enterprise multi-session version, which is the only Windows client-based operating system that enables multiple concurrent users on a single VM. Yeah, but somehow if it's the only Windows client-based operating system, uh, it's somehow it is the state of the art. This time it's the state of the art because it doesn't have uh, because we don't have any other Windows client-based operating systems that enables multiple concurrent users on a single machine. So we can say that it's a SOTA in this topic. And let's talk about Azure containers. Containers are a virtualization environment, much like running multiple virtual machines on a single physical host. We can run multiple containers on a physical or a logical host. And by logical host, I mean the virtual machines. You can either run the containers on a physical, for example, on a physical computer, like the ones that we are using now, for example, this laptop, or other cases that we have, and or we can run containers on a virtual machine, because virtual machines are typically a computer, a virtualized computer. Uh, and there is no need to manage the operating system. As I said earlier, containers are lightweight and designed to be created, scaled out, and stopped dynamically. Uh, and Azure Container Instances, it's a service, Azure Container Instances offer the fastest and simplest way to run a container. Uh, I think we do not get charged for Azure Container Instances. We just pay for the Azure container. We do not pay for the service that we are using here. Uh, because sometimes some services are charged separately from each other. For example, we are using Azure containers. We're going to get charged for it. We can use Azure Container Instances free. You can use this service free, but sometimes it's not free. There are some other kind of services that we are going to get. Uh, we have to pay for it. Uh, there is another concept in Azure named Azure Functions. This is again another service that we can use. Azure Function is an event-driven serverless compute option that doesn't require any virtual machines or containers. for example, we can use Azure function if we want uh, for example, I can say if you want to turn off the lights, we can use an Azure function because it's just a function. We want the function to be run in a specific time, for example, in a specific days. We use Azure functions. It doesn't. We do not have to pay for another virtual machine or a container to do this small function, to do this specific function. We use Azure function to do that. Uh,
Can we
function.
schedule Azure functions? Can we schedule Azure functions?
Yeah, we can tell them when to uh, when to be launched. We can tell it when to be launched. For example, you can be launched. You have to be launched at 12 o'clock at noon. For example, to turn off the lights. We can use these kind of. I think they are using Azure functions in IoT. I think that it's just a function. If you want to run a simple function, you just use Azure function. It doesn't. You don't need to uh, get another virtual machine or a container for that purpose.
Azure
And
functions should be called in one container or one VM or
yes, it could be called in a
should
machine.
be or
It's uh,
or can
we
we
can
call
have Azure functions in a virtual machine in a virtual machine. I don't know about the containers. We can have. Uh, I think we cannot use Azure functions in Azure containers. I don't know. I have to search for it. But we can use them in a virtual machine. But it says it's not necessary to have uh, a virtual machine for it. Uh, and in this model, you're only charged for the CPU time used while your function runs. And for this purpose, that we are charged only for the CPU time, it means that a virtual machine is running in the background. And for this service, we are charged just for the CPU time, not anything further. We're just charged for the CPU time. Any questions here or from the previous slides, right? And there are some application hosting options. There is a service named Azure App Service that enables us to build and host web apps, background jobs, mobile backends, and RESTful APIs in the programming language of our choice. And it has automatic scaling. It is highly available, supports Windows and Linux. Uh, it also enables automated deployments from GitHub, Azure DevOps, or any other Git repo that supports continuous deployment models. And with app service, we can host most common app service styles like web apps, API apps, web jobs, and mobile apps. Uh, and I think, yeah, this is the last topic of this presentation, the virtual networking. Azure Virtual Networks provide the following key networking capabilities, as you can see in this slide. Isolation and segmentation, internet communications, the communication between Azure resources, the communication between on-premises and Azure resources, the route network traffic. We can filter the network traffic, and we can uh, just say which type of routing protocol it can use for the network traffic, and we can connect virtual networks to each other. Uh, The first one was isolation and segmentation. Uh, we create for we it can create multiple we can create multiple isolated virtual networks or VNs. We can define a private IP address space by using either public or private IP address ranges. Uh, IP range only exists within the VN and it's not internet routable. And that's what it makes it isolated. And by using uh, ranges of IP addresses, we can segment our uh, virtual network into different subnets. The other one was the internet communication. We can assign a public IP address in order to enable the incoming connections from the internet. And that's simple. Uh, the other one was communication between Azure resources, and we can communicate between Azure resources securely in two ways. VNs can connect virtual machines and other resources such as the app service environment that we mentioned for for example, for Power Apps, Azure Kubernetes service, and Azure Virtual Machine scale sets. Virtual networks can connect these resources that I said, and you can see them here. and and again it can connect service endpoint and the other way is the service endpoints can connect to other Azure resource types such as Azure SQL databases and storage accounts. And there's nothing else to say here. And we can also uh, communicate with on-premises resources in these three kind of ways. Point to site virtual private network. Uh, it's the VPN. It's the just the definition for point to site VPNs. For example, we want to use uh, the network of our organization from outside. For example, we're sitting at home, we want to just connect to the virtual network of our organization. That's the that's what Azure Virtual Networking, uh, that's what it provides us. Uh, and the other one is site-to-site virtual private network. And in site-to-site, for example, organizations that are using Microsoft Azure Virtual Networking can connect to each other and use, for example, their data information and etc. Uh, and there's another thing called Azure Express Route. It again has a uh, similar definition, and it kind of does the similar thing as the other ones do. Uh, and we can use route tables. Uh, Azure Virtual Networking allows us to use route tables, uh, and they allow us to define rules about how traffic should be directed. You can create custom route tables that control how packets are routed between subnets, or we can use the BGP protocol, Border Gateway Protocol, that works with Azure VPN gateways, Azure Route Server, or Azure Express Route to propagate on-premises BGP routes to Azure Virtual Networks. Uh, and we can filter the network traffic. Network security groups are Azure resources that can contain multiple inbound and outbound security rules. You can define these rules to allow or block traffic based on factors such as source and destination IP address, port, and protocol. Network virtual appliances are specialized VMs that can be compared to a hardened appliance. A network virtual appliance carries out a particular network function, such as running a firewall or performing wide area network optimizations. These are the capabilities of Azure Virtual Networking. You can filter the network traffic in these kind of ways that are mentioned here. And the last part is the connection between virtual networks. You can link virtual networks together by using virtual network peering. Peering allows two virtual networks to connect directly to each other. Uh, Network traffic between peered networks is private and travels on the Microsoft backbone network, and it doesn't get out on the internet. And that's it for today's presentation. And thank you for listening.
Thanks so much.